Hello, welcome back. Second lesson of electrolysis. As you can see, our classroom has been hugely updated by this glorious poster donated by Miss Hunter. So thank you very much, Mrs. Hunter, for that one. Just about to say it, I can't really do much about the board. It's already screwed onto the wall. So, bit of colour. For those of you that have been asking me where we're actually filming, I'll just quickly show you. This is where we're filming, inside my gym at the end of my garden. So, back to the lesson, and slightly bad planning, it's not a lot of battery, so might have to be a bit rapid on this one. Right, second lesson on electrolysis. We're looking at the electrodes, specifically what's happening at the electrodes in terms of the electrons. Now, this as a starter on the board for you, just to have a little recap on last lesson. Have a go at those questions, please write them in your books. I would advise you to try and do it without using your notes, and do it in a different colour pen, going back through your notes as well, so you can see what you can remember and what you can recall, and then what you can actually apply with your notes in front of you. And then when you mark, do it in green please. So, hit pause now, and then we can go through these. Right, so, anode, positive or negative? Well, one little reminder thing about anode. Anode, addition, addition is a positive sign. So, positive is our anode. One little way of remembering it, some students spell it that way. With that positive, the cathode must therefore be negative. Okay. The solution of ions is called the electrolyte. That pen is quite hard to see. Let's try blue. Electrolysis separates what compounds? Well, we talked about simple, covalent or ionic. Hopefully you can all remember that it is indeed ionic. And for those of you that push it up a little bit further, it is molten or ionic compounds in solution. Metal ions are always positive. Okay, they are positive, which means non-metal ions must be negative. Remember, metals lose electrons when bonding, so they must become positive. Non-metals gain electrons when bonding, so they must become negative, as they have more electrons than they do protons. Metal ions go to, well, think about opposites attracting. If the metal ions are positive, they must therefore go to the negative cathode. So they go to the cathode, which means the non-metals go to the anode. Okay, hopefully you did alright on that one. Ping it in the comments on the frog assignment, just so I can know how you're getting on. It's really, really useful for me, so I know how to plan the future lessons, and know how you guys are getting on, and what content you'll be able to cope with, and what you're finding tricky. So, moving on from here, what we're going to look at today, guys, is the electrodes, what's happening with the electrons at those electrodes. Now, easiest thing to do to start off with, I always think, if possible, I like to do this, draw a diagram. So, what we're going to do, we're going to look at zinc chloride. Okay, now that was one of your homeworks, one of your assignments that you had for the last lesson, zinc chloride. So it should be familiar. That didn't wipe off particularly well, did it? What we're going to start off by doing is drawing out, again, our electrolysis vessel. Okay, and we're going to have our two graphite electrodes in here, like so. And then we're going to have our molten solution. Again, we're still looking at molten at the moment, of zinc chloride. Now remember, okay, this one is going to be our cathode, and this one is going to be our anode. Okay, I'd like to draw this in your books, please. Cathode, anode. So we've got negative and we've got positive. Now from last time, remember, and what the recap we just did, going over to the cathode, we've got zinc chloride, then we've got the positive zinc, the zinc's 2+, zinc 2+, okay, but the important thing is you remember it goes to the cathode. And on the other side, we have got negative chlorine ions going to the anode. Now we need to think about what's going to happen when they actually get there. Now one thing, okay, that I'll ask you guys to write down and do your best to remember. Now this is one of the more memorable things we'll give you in terms of how to remember what is happening with the electrodes is oil rig. Okay, oil rig. So I'll write that at the bottom like so. Now, oil rig is all to do with electrons. So everything I say now is about electrons. Oil rig, oxidation is loss. Have a little think about what the other one could possibly be. If you've got oxidation is lost, reduction is gain. Okay, oxidation is loss, reduction is gain. This is all referencing electrons. So oxidation is loss of electrons, reduction is gain of electrons. So could you make sure you write that down, please? Now thinking about what's going on either of these sides, the zinc is positively charged. It wants to become zinc metal. Okay, it wants to become zinc metal, the element zinc. And the chlorine here is going to want to become chlorine gas. Now, in elemental state, all substances have no charge. No charge. So the zinc, having a positive charge at the moment, it's got to do one of these two. It's got to be oxidized or reduced. Now, oxidation is loss of electrons, reduction is gain of electrons. The zinc is already positive, so it's got more protons than it has electrons. It wants to have the same number, so it's got more protons than electrons. So over here on our cathode, the zinc is going to gain electrons. It's going to be reduced. It's going to be reduced. So over on this side, what we have is reduction. We're going to have a gain of electrons. We're going to have a gain of electrons. And over on the other side, chlorine's negative. Okay, it's got more electrons than it has protons. Again, we want them to balance out. The only way that can happen is if they lose that extra electron that they've got. So we've got oxidation happening on the anode side. Oxidation is loss of electrons. So over on this side we have oxidation, the loss of electrons. So at the cathode we have reduction, at the anode we have oxidation. So layering on to what we already had before, metal ions go to the cathode, they get reduced. Non-metals go to the anode and they get oxidized. They lose electrons. It's a loss of electrons. So then we've got to think about what our products are going to be. Now, if we think back to our basic electrolysis equations that we had last time, this one, for example, we've got zinc chloride forming two products. Two products this time. Have a little think what those two products would be if you start with zinc chloride. Two products would be zinc, and the second one would be chlorine gas. So zinc metal and chlorine gas are what you get here. Now the last part I want to do with this, and I do say it's the last part, so it's a shorter one than last time because there was a lot of practice I would like you to do for this, is showing you something that's called half equations. We've covered what's happening in terms of the movement of electrons. Half equations simply do that. They show the transfer of electrons. They show which species is gaining electrons and which species is losing electrons. So I'm going to take this off and then we're going to look at a half equation specifically for our zinc and our chlorine. Okay? So we shall wipe this off. Again, if you haven't got it down yet, just rewind the video, press pause, that's the beauty of it, and then fill in as needed. Again guys, most of the notes I'll be putting on the board, but if you want to make additional notes from the way I'm speaking around the topic, then please do so. So, let's take zinc chloride. So we've got ZnCl2. The reason it's ZnCl2 is because Zn is a 2+ charge, chlorine is a -1 charge. Think about ratios, we've talked about this before. How many chlorines do you need to satisfy the 2+ charge on the zinc. You can always do the little switcheroo. 2 of those and 1 of those. So our formula is zinc chloride. You need 2 chlorines for every zinc. 2 products, zinc and Cl2. Gas, solid, liquid because it's molten. That's already balanced. I'm happy with that as it is. So we're doing half equations. Half equations. So half equations show the transfer of electrons. So they show which species is losing, which species is gaining. Get that definition down as well, please. Wipe that off. Again, if you want to pause it to write it down, you may do so. So let's take our examples here. We've got zinc going to the cathode, zinc 2+. So we're going to go with this one first. Now zinc 2+ wants to become zinc no charge, neutral. So we said what it's going to do is going to gain electrons. So we can simply add some electrons. Think about what letter might represent electrons. Fortunately, it's quite obvious. E. And it's a negative charge, so we put a negative charge at the top right hand corner. Goes to zinc metal. Now I'd hope that some of you here would notice straight away it's not balanced in terms of electrons. I've got a 2+ charge here, but I've only got 1 electron over here. So I have to balance it. And simple, just like the balancing equations, I just put a 2 in front of the electrons. I'm adding 2 electrons. Okay, I'm adding 2 electrons. So we've got reduction going on here. Reduction is gain. I'm gaining, adding 2 electrons over here. Now on the other side, we've got oxidation, and we've got the chlorine, Cl-. We're going to show the electrons on the other side, okay? The correct way of writing this is to have the electrons on the other side of the arrow. So we're going to write an arrow, and we're going to be forming our chlorine gas over here. So we can write Cl2, and over here we're going to add the electrons on this side as well. The charges have to balance out. Over here I've got +2 and -2, so neutral, and I've got neutral over there. This side I've got negative. Notice it's the Cl2. This is an easy trip up. I've got 2 chlorines over here, so I have to balance out by putting 2 chlorines over here as well. Now I've got 2 negatives on this side. So I've got to have 2 negatives on that side. It's got to balance out the charges as well. Not only balancing the atoms, but balancing the charges. So I'm going to add 2 electrons. Reduction, the electrons are on the left. Oxidation, the electrons are on the right hand side. These are tricky, okay guys, these are tricky. Doing half equations is a high level task, and it is a high tier. Practice these, and that will be the way to get around these, okay? So I'm going to set you some examples. I'm going to set you some work, some spreadsheets that I'd like you to write out. You don't have to print these out. You're not expected to print anything at the moment. If you have a printer and you can, then you can do so, but if not, you can just write them down. Have a go at these half equations that I'm going to send you. Use the notes you've written, re-watch the video if you need to, follow the rules as I've just shown you, and you should be okay with them, okay? We're not going to put state symbols on these guys, okay? Half equations, we're not going to put state symbols. So, that's your second lesson. The third one we'll tackle next week. I'm probably going to do the third one on electrolysis of aluminium oxide. We'll probably do that one first, and then we'll get on to electrolysis of solutions. I hope you're all keeping well. Please email me if you've got any questions. Put comments on the frog assignment so I know how you're getting on. And I'll see you next week.